Good morning. Good morning to all. Dear students, little bit late in sending the link due to some internet problem. Now, let us start our class today. See, in last class, we discussed about chemical reactions of alcohols. Today, we shall continue discussion on chemical reactions of alcohols. Chemical reactions of alcohols. So students, we discussed about the cleavage of R to OH. See, we studied some of the reaction where O to H bond breaks. Today we shall discuss some of the reaction where carbon to oxygen bond breaks in alcohols. Are you clear? See, we have to study first reaction, that is reaction with hydrogen halide HX. See, alcohol, you know, ROH, alcohol. When reacts with hydrohalic acid, HX, and we will get, see, RX, where carbon to oxygen bond breaks. See, in alcohols, you know, alcohols act as an electrophile as well as nucleophile. We studied in previous reactions where oxygen to hydrogen bond breaks. Are you clear? Today we shall discuss where carbon to oxygen bond breaks. Here, see, when alcohol reacts with hydrogen halide, we will get RX along with water. See, what are the reaction conditions? Reaction conditions is we have to use a Lucas reagent. What do you mean by Lucas reagent? It is nothing but it is a mixture of, see, concentrated HCl plus anhydrous zinc chloride. This mixture is called Lucas reagent. Are you clear? Always we will ask one more question. What is Lucas reagent? Lucas reagent is a mixture of concentrated HCl and anhydrous zinc chloride. That mixture is called Lucas reagent. See, when this Lucas reagent is used here, where R to O bond breaks, that is carbon to O bond breaks, and we will get RX. See, take particular example. When methyl alcohol reacts with hydrobromic acid in the presence of concentrated HCl and ZnCl2. So we will get CH3Br plus H2O. Are you clear? See here, the primary alcohol, secondary alcohol, tertiary alcohol reacts in a different way. See, Lucas reagent is also a test to identify whether the alcohol is primary alcohol or it's a secondary or tertiary alcohol. See, in Lucas reagent, in primary alcohol, it does not produce turbidity at room temperature. No turbidity at room temperature. No turbidity at room temperature. See, this is very important point you have to remember. See, if it is a tertiary alcohol, then if we use Lucas reagent. See, immediately a turbidity is obtained. Immediately turbidity is obtained. Turbidity is obtained. Are you clear? So one more question we will ask. How Lucas reagent reacts with a tertiary alcohol? If it is a tertiary alcohol, immediately it produces turbidity. If it is primary alcohol, no turbidity at room temperature. No turbidity at room temperature. Are you clear? Okay, we shall continue. When alcohol reacts with hydrochloric acid, it means a hydrogen halide. So we will get Rx and release of water molecule. Where this is nothing but an alkyl halide. Alkyl halide. You already studied this in first unit of organic chemistry. That is haloalkane and haloarene. Okay. Now you have to remember what is Lucas reagent. Lucas reagent is mixture of a concentrated HCl and zinc chloride is called Lucas reagent. Are you clear? What is Lucas reagent? A mixture of concentrated HCl and anhydrous zinc chloride is called Lucas reagent. Okay. Then we shall study other reaction. Again, I am going to tell you, see, when primary alcohol reacts with Lucas reagent, turbidity does not obtain at room temperature. If it is a tertiary alcohol, immediately turbidity is obtained. Then, see, alcohol reaction of alcohol with phosphorus tribromide, PRO3. Alcohol ROH, when it reacts with phosphorus tribromide, PbRO3, or even with phosphorus trichloride. You study this reaction in the preparation of haloalkane and haloarene. See, we will get RBr, where bromo haloalkanes are obtained. Again, plus, so we will get H3PO3. So it is nothing but 3 times. This balances again 3, and we will get H3PO3. Orthophosphorus acid. What is obtained? Orthophosphorus acid is obtained. When alcohol reacts with phosphorus tribromide, see, alkyl bromides are obtained, and along with phosphorus. So what is the name of this compound? Orthophosphorus acid. If it is H3PO4, then it is called orthophosphoric acid. That's all. Okay, so this is second. Then we shall study the dehydration reaction, which is called dehydration. See, alcohol, particularly I am going to write example CH3CH2OH, which is nothing but ethyl alcohol. See, when it is treated with concentrated H2SO4, at particularly nearly 443 Kelvin temperature. What happens? Dehydration takes place. Removal of water molecule takes place. Removal of water molecule is called dehydration. See, instead of concentrated H2SO4, in dehydration, we can use H2SO4. Instead of this, we can use see H3PO4, which is called orthophosphoric acid. Again, we can also use anhydrous zinc chloride acid or alumina. Alumina can also be used. These are important dehydrating agents which is used to dehydrate, remove water molecule from alcohol. One particular reaction which we are going to study is dehydration of alcohol by using concentrated H2SO4. Concentrated H2SO4. See, when CH3, CH2OH, when concentrated H2SO4 is used as a dehydrating agent, so alkene is obtained, particularly here ethene is obtained. See, CH2 double bond CH2. Very, very important reaction. Are you clear? So this is very, very important reaction. Every year we will ask. We have to study its mechanism also. Have to study its mechanism also. See, when ethyl alcohol CH3 CH2OH, when it is treated with concentrated H2SO4 on dehydration, alkene is obtained. What is the name of this compound? Particularly, ethene is obtained. Are you clear? Understood? So I will repeat again. Ethyl alcohol reacts with concentrated H2SO4 at 443 Kelvin temperature. It gives ethene. What you have to remember in this reaction? See, dehydrating agent. What are those dehydrating agent? Concentrated H2SO4 or orthophosphoric acid or anhydrous zinc chloride, or even we can use alumina. Are you clear? So this mechanism also you have to study. So we will ask one more question. Name the dehydrating agent used to dehydrate ethyl alcohol into ethene. You can use concentrated H2SO4, or you can use H3PO4, or even you can use anhydrous zinc chloride, or you can use alumina also. Are you clear? Now we shall study its mechanism. See, you have to study mechanism of dehydration of ethanol to ethene. We shall study mechanism of dehydration of ethanol to ethene. See, if you go through the annual examination question paper, every year you will get one question for 3 months. Dehydration of ethanol to ethene. So it carries by 3 important steps. We shall study step 1. So that is nothing but protonation of alcohol. First step is protonation of alcohol. Are you clear? First step is protonation of alcohol. See, this is nothing but ethanol, C, again O and H, which is nothing but ethanol. See, while writing the mechanism, write its complete structural formula, then only it will be clear. See, hydrogen atom, again hydrogen atom, ethanol. See, when it is protonated by H plus. See, in this dehydration reaction, we are losing H2SO4. Now, as this attacks, and you will get protonated alcohol. See, C, H, H, H. Again, see, two atoms are here. Again, this is oxygen and hydrogen atom attaches here. It gets a positive charge. Are you clear? So, this is called protonated alcohol. A proton is added to an alcohol. We will call this as protonated alcohol. Protonated alcohol. Are you clear? What is this? Protonated alcohol. Are you clear? See, when ethanol is treated with a concentrated acid, so it is termed as protonated alcohol. One proton is added to ethanol. Okay. Then second step is step 2. See, formation of carbocation. Formation of carbocation. Formation of carbocation. Are you clear? What is second step? Formation of carbocation. See, ethanol in a mechanism, it is very easy. When initial step and product, whatever there in the first step, that is the reactant in the second step, that's all. Now, this is nothing but C, H, which is nothing but again H, and protonated alcohol we have. Protonated alcohol. So, this protonated alcohol forms carbocation. See, H, again C will become, and elimination of water molecule takes place plus H2O. Are you clear? So this bond breaks and elimination of water molecule. See, formation of carbocation. How? By elimination of elimination of water molecule. By elimination of water molecule. Are you clear? See, water molecule is eliminated here. Water molecule is eliminated. Are you clear? Water molecule is eliminated. See, formation of carbocation and elimination of water molecule takes place. Now, we have to go for last step. So, that is the step 3. Step 3. See, ethanol, which is nothing but protonated alcohol. Then in last step, see, one proton is removed. So, deprotonation will call removal of proton. Removal of proton. See, again, carbocation, you have to write H. Then C, H. So this is nothing but a carbocation, H. So when one of the hydrogen atom, this bonds here and it eliminates. So you will get C, double bond C, H, again H. And one proton is eliminated. This is very important. One proton is eliminated, no charge, eliminated. So, one H is removed. Even you can write H plus, even you can write H plus. Okay? So, this is nothing but ethene. Are you clear? See, one proton is eliminated here. See, first step, protonation of alcohol, even in which can take a reversible reaction, you can write. See, ethanol, protonated alcohol is called. Again, protonated alcohol, by the removal of water, carbocation is formed. It is also a reversible reaction. And removal of proton, that's all. So this is nothing but the mechanism of dehydration of alcohol. We'll call this as mechanism of dehydration of alcohol. So in the mechanism of dehydration of alcohol, it carries by three important methods. That means steps. What are those? First one is protonation of alcohol, and second one is formation of carbocation. Second one is formation of carbocation, and third one is removal of proton. Are you clear? See, repeatedly I am going to tell you. You studied now the dehydration mechanism. Write the mechanism of dehydration of ethanol to ethene. Every year we will ask for 3 marks. Every year we will ask for 3 marks. See, this is nothing but protonation of alcohol, formation of carbocation, and removal of proton. Are you clear? You can easily go through this reaction, practice it, and you can easily write. See, in the last step, the removal of proton you have to write. Okay? This completes our study of mechanism of dehydration of ethanol to ethene. Mechanism of dehydration of ethanol to ethene. See, ethyl alcohol first you have to take. It is protonated, and next step forms carbocation by the elimination of water, and removal of proton gives ethene. That's all. So, shall I wrap? We shall study next part. In the dehydration, even secondary alcohol can also be dehydrated at a mild condition. See, secondary alcohol are CH, OH, then CH3. Secondary alcohol. It is a secondary alcohol. It is dehydrated in presence of H3PO, nearly above 80%, at just low temperature, then nearly at 413 Kelvin temperature. So we will get R, as it is dehydrated, R CH double bond CH2 plus H2O. Even the tertiary butyl alcohol, CH3, CH3, again CH3OH. It can dehydrate in still mild condition. So less temperature, nearly about 338 Kelvin temperature, and H3PO4 just about 20%. When drastic condition comes on decreasing. As more alkyl groups are there on the carbon atom, we can easily eliminate hydrogen. So we will get CH3, again double bond CH2, and again here CH3 plus H2O. Are you clear? This is the double bond. 1, 2, 3. Again CH3. So what is the name of this compound? So it is nothing but a propene. Okay. This is nothing but a dehydration reaction. Are you clear? Dehydration of secondary alcohol, dehydration of tertiary alcohol. Tertiary alcohol can be dehydrated less drastic condition as you compare to secondary and primary. Okay, we studied about dehydration reaction and we discussed about even mechanism of dehydration of the reaction. And next, we shall study about oxidation reactions of alcohol. A very important one. Oxidation reactions of alcohol. Oxidation reactions of alcohols. See, in oxidation, carbon to, suppose carbon, then oxygen, then hydrogen. And again, it is R means here, one H atom is here. Dear students, in oxidation reaction, carbon to hydrogen bond breaks, as well as oxygen to hydrogen bond breaks. See, one H from here, one H from here, and hydrogen is removed. Therefore, it is called oxidation. And it is also called dehydrogenation. It's called dehydrogenation. Dehydrogenation. Are you clear? In oxidation reactions of alcohol, you have to remember, see, carbon to hydrogen bond breaks in the alkyl and oxygen to hydrogen bond is also broken. See, one H atom from carbon to hydrogen, another H atom from oxygen to hydrogen. See, two hydrogen atom separates, H2 will be removed, and that particular reaction is dehydrogenation. Are you clear? It's called what? Dehydrogenation. Dehydrogenation. In oxidation reaction, what is the theory behind this? See, this is nothing but an alcohol. It is nothing but an alcohol. In this alcohol, oxygen to hydrogen bond breaks. And oxygen, see, carbon to again another hydrogen bond. This also comes. So here one, here two hydrogen atoms are removed. And the cleavage of oxygen to hydrogen bond and carbon to hydrogen bond takes place. This type of reactions are called oxidation reactions. Okay, this is the basic thing you have to remember about oxidation reactions of alcohols. Are you clear? Dear students, you have to remember, in oxidation, oxygen to hydrogen and carbon to hydrogen bond breaks, hydrogen atom eliminates dihydrogen atom, therefore it is called dehydrogenation. See, alcohol R, then CH2OH or CH2OH. So when it reacts with in the presence of an oxidizing agent, in alcohols, particular oxidizing agent used in chemical reactions are, see, first one is chromic anhydrous chromic oxide, CrO3, and strong oxidizing agent like potassium permanganate, KMnO4. Strong oxidizing agent like potassium permanganate and chromic CrO3 in anhydrous medium. And again PCC. See, pyridinium chlorochromic. Pyridinium chlorochromate. And we will abbreviate as PCC. Both CrO3 and PCC are mild oxidizing agent. Whatever potassium permanganate, strong oxidizing agent. See, alcohols, when it reacts with a strong oxidizing agent, directly carboxylic acid is obtained.
When it reacts with mild oxidizing agent, aldehydes are formed. That's all. Which is formed, aldehydes are formed. That you have to remember. Are you clear?
See, when alcohol is oxidized in presence of mild oxidizing agent like CrO3. What may be the product? An aldehyde. See, R, then CHO. R, CHO. See, H2O, H and O is removed. The hydrogen is dehydrogenated. And what is the removed here? Plus H2, hydrogen gas is removed. Therefore, it is called dehydrogenation. Are you clear? See, in the oxidation reaction, you have to concentrate on oxidizing agent. In the same reaction, instead of CrO3, you are going to use strong oxidizing agent like acidified potassium permanganate. Acidified potassium permanganate. So directly, what do you get? RCOH. Carboxylic acid is obtained. Are you clear? This two types. It is a strong oxidizing agent. Acidified, particularly acidified chemical. Are you clear? See, when alcohol reacts with a strong oxidizing agent like acidified potassium permanganate, carboxylic acid is obtained. In oxidation reaction, dehydrogenation takes place. In oxidizing agent, we are going to use two types of oxidizing agent. One is mild oxidizing agent, another one is strong oxidizing agent. In the mild oxidizing agent, the alcohol gets converted into aldehyde. In case strong oxidizing agent, alcohol is converted into carboxylic acid. Are you clear? That much you have to remember. And some examples of oxidizing agent. The examples of oxidizing agent we are going to use is, see, chromic oxide, PCC. What is PCC? We will ask. See, PCC is nothing but pyridinium chlorochromate. Pyridinium chlorochromate. So it is also a mild oxidizing agent. See, particularly one example which you are going to study is say CH3, CH double bond, CH, then CH2, OH. So it is nothing but 1, 2, 3, 4. Butene alcohol. Is it not? It is nothing but but-2-ene. See, when it reacts with PCC on oxidation. So we will get say CH3, CH double bond CH, and this CH2OH is dehydrogenated, and we will get an aldehyde is inserted here. Aldehyde plus H2. Are you clear? So this is nothing but 1, 2, 3, 4. It is nothing but but-2-ene or air. 1 or air. See, it is nothing but butanol and aldehyde is obtained. What is the oxidizing agent used? Oxidizing agent is PCC. Whether PCC is a strong oxidizing agent or mild oxidizing agent, it is mild oxidizing agent. Alcohols on using mild oxidizing agent, aldehydes are obtained. Alcohols on oxidation with strong oxidizing agent, carboxylic acids are obtained. That point you have to remember. Are you clear? Okay. According to your syllabus, you have to study. See, this is nothing but CH3, CH2, OH. On oxidation, in presence of oxidizing agent, pyridinium chlorochromate.
we will get butanol. An aldehyde is obtained. And this particular group CH2H is converted into what? CH2 by the removal of hydrogen gas. Therefore, it is called oxidization, and the particular reaction is called oxidation reaction. I think you are clear. Okay? Repeatedly, I am going to tell you this equation, and many times it is asked for your annual examination. Again, aldehyde or ketone or CH2OH and alcohol can be converted into aldehyde or CH2 or CO2 by using a mild oxidizing agent CrO3. So again, this aldehyde can also oxidize by using mild oxidizing agent chloric oxide to carboxylic acid. In the next step, this is possible. So directly an alcohol converted into carboxylic acid by using acidified KMNO as an oxidizing agent. Are you clear? By using acidified potassium permanganate, and alcohol is directly oxidized to carboxylic acid. By using mild oxidizing agent, alcohol is converted into aldehyde. We shall again study the oxidation reaction with copper as a catalyst see copper as a catalyst or CH2OH, copper as a catalyst at 573. It's a common well-known reaction. So again we will get an aldehyde CHO and aldehyde is used. Aldehyde is obtained. It is whether it is a primary or secondary alcohol, it is a primary alcohol. When primary alcohol is oxidized in the presence of copper at 573. What is the reaction condition here? Copper at 573. Again, we shall use a secondary alcohol CHOH. Again, it is nothing but a secondary alcohol. In the secondary alcohol, say this is nothing but an oxidation. We will get again this CHOH, and it gets converted into ketone or dash. Are you clear? If a secondary alcohol is oxidized, we will get a ketone. It is nothing but a ketone. What is the reaction condition? Copper at 573. Kelvin. Are you clear? See, already these reactions are there in your textbook. See, it is nothing but a secondary alcohol. When it is oxidizing in the presence of copper at 573, we will get ketone. And this secondary carbon atom, which carries the hydroxyl group, oxidation with copper with 573. So dehydration takes place again. Dehydrogenation takes place. You will get R C double bond O R dash. Are you clear? Go for tertiary alcohol. Particularly I will write CH3 COH, again CH3 CH3. It is nothing but tertiary butyl alcohol. It is oxidizing in the presence of copper as a catalyst at 573. See, dehydrogenation does not take place. Here dehydration takes place. Dear students, when a tertiary alcohol is oxidized in the presence of copper as a catalyst at 573 Kelvin temperature, not dehydration takes place. That is water molecule is evaporated, not only dihydrogen gas. See here, CH3, again C, which is double bond CH2, and this is nothing but CH3. and alkene is obtained. So it is nothing but 2-methyl pro 1-ene is obtained. What is the reason? See, you will get one more question. Tertiary alcohols, on oxidation, hydration takes place, removal of water molecule takes place. But in secondary and primary alcohol, during oxidation, dehydrogenation takes place. Hydrogen molecule eliminate. Here water molecule eliminate. See, you know in the basic class, in first only, in tertiary alcohol, carbon is not directly attached to hydrogen bond. This carbon is attached to 3 other carbon atoms. So this is nothing but CH3, this is nothing but CH3, and this is nothing but a tertiary. As carbon atom is not attached to directly a hydrogen atom, so therefore dehydration takes place. Water molecule is completely eliminated. So this molecule is completely eliminated. So therefore an alkene is obtained. That you have to remember. Are you clear? So this is nothing but dehydration reaction of alcohol. See this is nothing but oxidation reactions of alcohol. Okay, you studied oxidation reaction with copper at 573 in primary, secondary as well as tertiary. So this completes our study of chemical reactions of alcohols. We shall begin with chemical reaction with phenol. Are you clear? Oxidation reaction we completed. Now we shall discuss. Say the chemical reactions of phenol. Chemical reactions of phenol. See, what do you mean by phenol? This is nothing but, see, this is phenol. OH, phenol. See, in phenol, hydroxyl group is directly attached to sp2 hybridized carbon. In phenol, hydroxyl group is directly attached to sp2 hybridized carbon. So it can easily undergo, therefore, electrophilic substitution reaction. Are you clear? When phenol reacts with in nitration, that is in dilute nitric acid, and even in concentrated nitric acid. In dilute nitric acid, see, ortho and para products are predominant. See, when phenol reacts with dilute HNO3. What are the products for? See, we will get it. So this is nothing but phenol, and this is nothing but orthonitrophenol, and another molecule of para-nitrophenol is obtained, OH. So this is para-nitrophenol, and this is nothing but orthonitrophenol. And this is para-nitrophenol. Are you clear? So we shall continue our discussion in the next class. Are you clear? We started the chemical reactions of phenol as a time. Okay, thank you, students.